Part 3 of Chapter 3 takes another look at loan calculations. Part of your monthly payment decreases your principal or your original amount of your loan, and the other part goes towards the finance charge. In this summary statement, we have what's called an amortization schedule, also called a payment schedule, for a loan that was worth $100,000 with an interest rate of 7.5% over the course of 15 years. So, using that monthly payment calculator, we could determine that $927 is the monthly payment. Take a look at the payment schedule for the very first year of this loan. And what do you notice? Pause the video and then hit play after you've figured it out. So, looking at this payment schedule, we can see that in January, the amount paid towards the principal was $302. By the end of this first year, the amount that went towards the principal increased to $320. So these numbers were increasing, whereas the amount that went towards interest started at $625 and ended the year at $603. So all of these numbers were decreasing. And that's simply because the loan balance is going down over time. So when we charge that same interest rate on our loan balance, it's not going to produce as much interest. So you don't have to pay as much towards interest. So the remainder of your monthly payment goes towards your principal. Keep in mind that any extra that you would pay towards your loan on your monthly payment would go automatically towards your principal. And as we said in class, this is what can cause your overall interest of the loan to decrease. As stated on the previous slide, part of your payment goes to the interest accumulated for the month, and the other part goes to the principal of the loan. So what happens is you get a curve where earlier in your loan agreement, more goes towards the interest, and later in the life of the loan, more goes towards the principal. So here's an example of another yearly payment schedule. The loan started at $35,000 in 2010. Nearly $3,300 of your monthly payment went towards interest. And then in the last year, only $200 went towards your interest, whereas the rest of your monthly payment, which looks to be about $4,000, went towards the principal of the loan. However, what if we knew how much we could afford per month and wanted to know how much time it would take to pay off the loan? So we could take that original monthly payment calculator and we would solve that equation for T to produce what's called a length of loan formula. So since T was the exponent in our previous formula, we use logarithms to solve for that exponent. And by knowing how long it would take to pay off the loan, it might make the decision easier when considering a loan and the size of a loan itself. So as with the previous calculator, I've created a formula on Desmos for you to use. So go ahead and type this link into Desmos, and as before, once you've opened it, save it to your Desmos account. So pause the video if you need to type in the link and then hit play when you are ready to go. So here is the Desmos calculator. If we are looking at the first example from the previous slide, Bryant wants to borrow $25,000 to purchase a car. After looking at his monthly budget, he realizes that all he can afford to pay per month is $300. The bank is offering a 5.9% loan. What would need to be the length of his loan so that he can stay within his budget? So this time, we are still working with the principal of the loan, the rate of the loan, but now we have the monthly payment and we are solving for the length of the loan. So going back to the Desmos formula, notice instead of M for monthly payment, I use X to represent that, and then G of X represents the number of years that I'm solving for. So our principal is $25,000. Our interest rate is 5.9%, and I am solving for a monthly payment of $300. So that means it would take nearly 9 years to pay off this loan. That is quite a long time for a loan for a car. Most banks usually only offer loans up to 7 years. So in this case, he either needs to shop around for a better interest rate or increase his monthly payment or find a car that is less than $25,000. Looking at example number 2, what impact would an increase in the monthly payment of $50 have on the length of the loan? So instead of paying only $300 a month, how would this change if it was $350? So right now we are at 9 years. By adding an extra $50 a month, it takes us to a little bit more than 7. So it seems that this is a little bit more doable. But even if we add, say, about 25 more dollars on top of that, then we are down below 7 years. And lastly, example 3, Bill can afford a monthly payment of $475. He wants to take out a $20,000 loan at 4.25% APR. What should the length of his loan be? How much will he pay in total, and how much in interest? So our principal, or P, is 20,000, R is 0.0425, and our X value would be 475. So notice it would take him about 3.8 years to pay off this loan. To answer how much will he pay in total, we would take the length of time multiplied by 12 to determine how many total months that would be, and then multiplied again by the monthly payment. So the total amount of this loan would be about $21,700. And then we could take that and find the difference between that amount and the original amount of the loan. So he would be paying almost $2,000 in interest for this loan, again, over the course of about 3.8 years. This section was pretty short, so if you have the time today, I would go ahead and continue working on those application questions to get a head start for tomorrow. And just a reminder, you should be completing up to question 15 before class on Monday.